Welcome to StarTalk Chat Room. This is a deep dive into the cosmos, and we're featuring episodes 7 and 8 from Cosmos Possible Worlds. And later we'll be joined by planetary scientist Carolyn Porco to talk about Cassini at Saturn. But right now, let's get into episode 7, titled The Search for Intelligent Life on Earth. So this episode opens with a shot of the current world's largest observatory. It's 500 meters in diameter.
Wow.
And it's called the Chuck. Hey, Chuck.
Hey, how's it going? See?
This is StarTalk in the Coronaverse.
That's right.
Did I invite you to this? How did you show up?
I just hacked in, man. You know what I mean?
It's called the FAST telescope, which is a brilliant acronym. So it's 500 meter aperture spherical telescope, and It's in China. And we'll tell you more about it in just a minute. But to get images for it, it's so large you can't just take a handheld camera and photograph it. So we had these drones that just ascended right up the middle of it, and then the whole telescope comes into view.
Wow.
It's so large; it's a mile in circumference.
Wow.
Yeah, it's just crazy.
That is mind blowing.
Yeah, and it's large for several reasons. Radio waves themselves are large, and it's a radio wave telescope. So radio waves can be anywhere from a few centimeters, small radio waves.
Right.
In fact, they're microwaves. So you
Sweet.
That's sweet.
Yes. There you go.
The short end of radio waves are called microwaves, and then just gets longer and longer and longer. So this telescope can receive radio waves from the universe and then focus them. So you have to be big just to receive big waves. But also, radio waves don't carry much energy. So you want as much of a collecting area as possible to get as much of that signal, whatever it is and wherever it's coming from in the universe, so that you can take it, decode it, and figure out what the hell's going on.
Sweet.
And what's interesting about radio waves is they pass through obscuring dust and gas in the galaxy. So many of the pretty pictures you see from Hubble, they're beautiful because parts of it are blocking views from behind, or they're glowing red or green or yellow or blue. And so it's very beautiful, but it's obscuring your vistas to the rest of the universe. Radio waves pass right through that.
So radio waves pass through these things that would otherwise obscure our view of the of the universe.
Exactly. So if you're aliens and they have technology such as we, and they're smart such as we, or at least we define ourselves as being smart, then they would figure out, as we have, that radio waves would be ideal modes of communication across the galaxy with what would be other alien life. Right? Because you don't want it stopping in some gas cloud. What good is that?
Right.
That'd be a waste. So
unless there's a life form that lives in the gas cloud.
Yeah, but okay. So then you wouldn't need radio waves. You can use some other form of light to stop at them in the gas cloud. And so other bands of light just don't have this ability to penetrate the clouds the way radio waves do. So radio waves become a very efficient means of sending signals and receiving signals if you're going to search for extraterrestrial life. Now,
so when you look at our SETI array of all these, dishes,
SETI, so the search for extraterrestrial intelligence, right?
Yes.
Mm-hmm.
So, is it most likely that if we receive communication, that it will indeed be through radio waves?
I'm just saying, if they want to talk across the galaxy, that's the best way to do it. Unless they figured out yet. Here's what's a little scary. We only discovered radio waves, 120 years ago, 130, Heinrich Hertz and a few others in the late 19th century. So if someone sent signals to Earth during the Roman Empire, there's still what we would call intelligence on Earth, but they would have no clue that someone was trying to yap at them from across the galaxy. So imagine that there's some other means of communicating we have yet to discover that's even better than anything we've invented, but the aliens have figured that out.
Wow.
They could be yapping at us right now, and we're just
Exactly.
oblivious.
It's funny because it's what you say makes so much sense in that I'm just picturing an ancient Roman with a radio right now, just twisting the dial, going, "There is nothing on this thing." I mean, yeah,
Well, that's right. So who are we to say that radio waves is the be all and end all of how you would communicate through the galaxy? They
right,
could have come
right.
up with something as advanced compared to our radio waves as radio waves are compared to Romans just screaming at each other across the countryside.
Right. So, could you? So, radio waves. I mean, are they superior or just different than light or different spectrums of light?
Yeah,
Let's.
that's a great question. So we know the rainbow: red, orange, yellow, green, blue, indigo, violet. Roy G. Biv, if you want a way to remember that. And we used to think that's just everything, and that's it. And then you find out no, there's like infrared on the other side, and you keep going, and you keep making the wavelengths a little longer. You get to infrared, then you get to microwaves, you get to radio waves. How about on the other side with the violet? You can make wavelengths shorter, go from violet to ultraviolet, and then you go to X-rays and then gamma rays. These are the words we have to describe the entire electromagnetic spectrum. All of it is, quote, radiation of different wavelengths. Radiation has gotten a bad rap in common parlance. We think of it as whatever's bad for you. And I
Right.
get that. I understand that. But speaking physically about this, all of these waves are some form of radiation. And only some varieties of it are damaging to you. So X-rays, you don't want to be around X-rays too much.
Not too much.
Okay. I figured this out when I was a kid, right? I'd be there in the dentist, right? And they're ready to take an X-ray. And what does the X-ray technician do just before they take X-ray?
They leave the
They
room.
leave the room.
It's like, oh, you're totally safe. I'm just going to go over here.
Well, if you're leaving the room,
Behind,
why is this an okay thing?
right.
I remember thinking this when I was like 9 years old.
Why is she behind a blast shield? And I'm and I'm getting zapped.
I remembered thinking that.
Right.
So yeah, X-rays in low dose can be very beneficial to diagnosing your health and your particularly if you have broken bones and things. Gamma rays have other consequences. They get in and start messing with your DNA.
Okay.
And who's the most famous gamma ray?
The Hulk.
The Hulk, of course.
Yeah.
Right. So we have evidence from DC Comics that excessive gamma ray exposure turns you into the Hulk, but only when you get angry.
Only when you get mad. Right. Exactly. And honestly, seriously, he just needed a therapist. Bro, you got anger issues. You got anger issues, bro. All you need is a therapist. All right. And we can work this thing out.
Exactly. I thought about it that way. That's a whole other angle on it.
Yeah.
What another favorite? There's a meme out there called the Credible Hulk. Have you ever seen that?
No, but that sounds great.
Okay, the Credible Hulk. It's you don't want me to be angry. You don't like it. You won't like it when I'm angry, because if you don't give me proper evidence and peer-reviewed research journals supporting your claims, I get angry.
I like that. The Credible Hulk.
So anyhow, so there you have it. And so this Chinese telescope, we used to have the largest in the world in Arecibo, Puerto Rico. And that was the largest, like, for decades. For 50 years, that was the largest telescope in the world. And so now the single largest is in China. So Chuck, let's get to my interview with Jason Clark, one of the executive producers of Cosmos Possible World. He became a good friend. He was executive producer from 2014 as well, Cosmos, A Space-Time Odyssey. He has some interesting films in his portfolio, by the way. He did Stuart Little.
Really?
Yeah. And he did what's the one with the talking dog? Mr. Peabody. Yeah, so he's got quite the portfolio.
Sherman and Peabody. Yeah. Cool, man.
So I asked him what was his favorite scene in all of Cosmos. And guess where that took us? Check it out.
Ah.
There's a great scene, one of my favorites, I would say, is when you go to China to...
World's largest radio telescope is there.
Yeah.
Yeah.
And it's, I don't remember, but I think it's a half a kilometer across.
Well, it's a mile in circumference. That's
Yeah.
a good way for Americans to think about it. It's huge, largest in the world.
And
It
you're
dwarfs
there.
the previous largest one, which was in America.
Yeah.
America used to have the biggest one. We don't have the biggest one
The
anymore.
one in Puerto Rico.
Yes, the
Yeah.
Arecibo, Puerto Rico, that
Yeah.
dish. So what it means is, if there's a alien message in the din of cosmic noise, the most powerful telescopes in the world may pick it up. If they do, it'll be the Chinese telescope first.
Oh, wow.
So the first scientists they will encounter will be Chinese.
So have there ever been these moments where you've actually believed maybe that's a real signal?
I'm not authorized to
Is this...
turn off the cameras right now. No, but that scene was an attempt to convey to the viewer, here we are either listening for signals or maybe even sending signals for intelligent life, yet there's stuff going on underfoot
Yeah, so
in our own backyard.
So this planet, which is, which most people take for granted, it's what we've grown up on, it's all we've known, but at the same time, there's so much going on in a way that we're not aware of, whether that's, bees and how they live. And
The
how
bee story. Oh
that's
my
an
gosh.
incredible story this
The
season.
bees, you're a busy bee, usually means you're busy doing nothing. You just moving air around, and there they are. I learned a lot too. I'm an astrophysicist, but I don't carry expertise in every topic that I discussed that was scripted and reviewed by other scientists, where it's their expertise.
Yeah.
So that's another sort of unique aspect of this, the scientific intersection that, again, the EP would look over that, right?
Yeah, so each episode we sent the script to a series of experts that we had hired, and each episode was picked apart because not only do you want this kind of what's the new thought and idea, but you want one that's been proven or vetted scientifically enough that it's worth repeating.
Right.
Because some ideas are so early in their discovery that they haven't gone through the...
Well, an important element that Anne persistently introduces, which enables the storytelling at the level that it is we will distinguish between established science and science that's just on the edge.
Yeah.
And so if it is this, then this could be true. So we're very honest, scripturally honest.
Yes.
Scripturally? Scriptures.
The scriptures are honest?
Scripturally,
Yeah.
honest about the science that is speculative versus the science that's established.
Yeah. I find that to be, there's so much detail. It's very rich this season, and there's so many stories. And going back to the radio telescope, the idea that the natural world that surrounds us has so many stories that have yet to be told, that may teach us about how life could exist elsewhere.
Oh, wow, man. So that, first of all, fascinating stuff. And more importantly, what the hell is up with America? Okay? What is going on? All right? Seriously, what is up with that?
So the whole point of the episode was to use that as an excuse to say, here we might be using telescopes such as this to send signals to potential aliens or vice versa to receive them, but when in fact we have evidence of intelligence on Earth that we've overlooked for not only centuries but millennia.
Right.
And so right there in episode 7, we introduce to you, perhaps for the first time, the intelligence of bees.
Sweet.
Now, there's, no pun intended. Now, there are bee lovers out there who think of bees as producers of honey. And of course, the vegans don't eat the honey.
Right.
And so bees are
busy. Honestly, vegans, it's bee vomit. You can't, come on. Seriously. You can't bring yourself to eat bee vomit. It's not like you're hurting the bees.
No, you're missing the opportunity. It's a bee barf.
Bee barf. There you go. Bee barf. It's like, come on. I got a feeling the bees are feeling just a little superior every time we eat a little honey. They're just like, can you believe those humans scarfing down our barf. Scarfing our barfing? Really?
So, first person I heard call it bee barf was David Brenner, the comedian.
Oh, that's right. Philadelphia comic David Brenner.
Yeah. I heard him say that, I think, when he was hosting Johnny Carson. This was now 800 years ago.
I was about to say, who's Johnny Carson?
But in there, he was 2 hosts ago from Jimmy Fallon of the Tonight Show. So we explore bees, and there's stuff I didn't know, as I made clear in that interview,
right?
That bees, when they're in the hive and they're just sort of, there's a waggle dance that they do where they sort of flap their wings and
shake their butts.
And they jiggle their abdomen.
That's right.
They're communicating with each other, not only distance but azimuth, and they're giving coordinates of where they just came from.
Yes.
And so it's 3 coordinates. If you want to know something in 3-dimensional space, you need 3 coordinates. So you need, in this case, would be azimuth, altitude, and distance. That would uniquely get you to a place. They are communicating this. And as far as we can tell, we can justifiably say bees are using abstract symbolism to communicate information. And that's what mathematics is.
Wow.
So this is Cosmos at its best, where it just gets a cosmic perspective. In this case, an Earth-based biological perspective on what you always thought you were in your relationship to the world around you.
Mm-hmm. That's I got to tell you, it's actually somewhat elegant and poetic.
Yeah, I agree.
Yeah.
Now, Chuck, you didn't. I'm surprised you didn't cue in on the fact that I did not answer his question whether we've received signals from aliens yet.
I know you said I'm not authorized, and he kind of let that go.
Yeah.
But here's why I didn't again. But see, here's why I didn't. I let it go because I've actually been with you in your office and eavesdropping while you were on the phone with somebody from the Department of Defense, and I was like, you know what? This ain't none of my business. I don't need no drones coming over to my house. I'm not even going to ask him what that was about. I'm not even going to ask him what that was about. It's none of my damn business. Mind your business.
You don't want a drone hovering outside your kitchen window.
That's all I'm saying.
Here's my point. We somehow believe that the government is some all-knowing, all-powerful entity, where if aliens were communicating with Earth, that somehow only the government would receive the signal.
Right.
Well, the government doesn't have the biggest telescopes in the world. Astronomers do. And we're not part of the government. We're a network of folks, and we communicate with each other all the time. We share data.
Right.
And there's a scene in the movie Contact where the Jodie Foster character is receiving signals from aliens, and the government comes in. We're going to shut this down. And she said, no, not until I send out this signal. She said, to whom? To everyone.
Right. There you go.
This is not a signal just to the U.S. military. It's a signal to everybody.
Yeah. Well, and, somebody like you probably has to say that. So,
Here's my final thought before we go on to our next half of this segment with Carolyn Porco.
Okay.
Good friend and colleague. Here's a question that I just live with, okay? We say, let's look for intelligent life in the universe. That's what the I is in SETI, the search for extraterrestrial intelligence. All right. That presupposes that we are the measure of the intelligence we're looking for. Okay. Well, get a species that's slightly more intelligent than we are. Okay.
Okay.
Would they, A, judge us to be intelligent? And even if so or not, would they be able to communicate with us? So, for example, you can rank, quote, below humans, other intelligent life forms on Earth. So dolphins, elephants, big-brained mammals out there. chimpanzees. Are we having a conversation with any of them? Are you sitting down with a chimpanzee? Well, what do you feel about the state of the world today? No. We have not had any meaningful conversation with any other life form that we would consider intelligent that's slightly less intelligent than we are. Why believe that some other life form, slightly more intelligent than us, could sit down and have any kind of meaningful conversation with us? That's the skepticism with which I approach this search.
So really, we could be Joey from Friends looking for Jim Carrey in Dumb and Dumber. And aliens are just like, look at these idiots, and there's no reason to talk to them.
No, it could no. I can do one better than that. It could be Stephen Hawking telephoning Albert Einstein, and the aliens will say, "These idiots."
That is too fun. Oh my God! So, oh man, that's so crazy.
That's how you need to think about this.
Yes, it's like two of the smartest people in our human existence.
Ever. Yes.
Ever. And they're talking to one another, and the aliens hear two babies just going,
That's right.
Oh my God, that's scary. That's scary.
Saying.
Oh, there you have it.
Well, we got to throw to commercial from
All right.
StarTalk Chat Room. Deep dive into the cosmos. When we come back, we'll explore episode 8 with a guest on the show, Carolyn Porco, a friend and colleague, and she was head of the imaging team at the Cassini spacecraft to Saturn. Yeah. We're back from break. StarTalk Deep Dive. Now we're going to talk about episode 8 of Cosmos Possible Worlds, titled The Sacrifice of Cassini. Sounds biblical, doesn't that, Chuck?
I have to tell you, it was, first of all, it's a great episode. Secondly, I will never forgive you for making me feel sorry for an inanimate object.
There was nothing.
I was so sad. I was so sad for Cassini. I was like, oh my God.
And Chuck, and you even had nothing to do with it. Let's bring someone on who did.
Exactly.
And get a real access to emotion. All right. Let me bring on Carolyn Porco. She's a friend, a colleague. We're about the same station in life professionally. So we've known each other like since graduate school. Carolyn,
Forever.
How you doing, Carolyn?
I'm doing great. I'm actually doing great.
Excellent.
Thank you.
And I've always called you Madam Saturn. And that was with deep affection. Were you okay with that?
I love it, Neil. I really love it. I have to thank you for it.
Okay.
That's one of the best nicknames I've ever had. I had older brothers, so you can imagine all the nicknames I had, but this one's a good one.
That's funny. And by the way, Carolyn, let me just say that you look great in the episode. For those who haven't seen it, Carolyn is in it.
Oh, yes.
Thank you.
And you've been a longtime friend of StarTalk. I just want to thank you for that. You've been there for us many times. And for those that don't know or don't remember, you were a leader of the Cassini Imaging Science Team. And just give us a note of what that means. Because people don't, I think they think of a spacecraft as just maybe just one antenna or something. They don't know the full sort of getup of what these things are.
The Cassini spacecraft carried something like 12 investigations, and one of them was a camera system, which really meant there were 2 telescopes, instruments. And so the Cassini instrument set were 2 telescopes, we call them cameras, and they operated mostly in the visible portion of the spectrum. So they basically saw what our eyes see. We went a little bit into the ultraviolet, a little bit into the near infrared, but it was basically the extension of our senses. They produced the highest resolution images that were taken by Cassini. And so the scientific objectives that the imaging team, my science team members and I, wanted to do were very broad in scope. They covered everything you could see, from the atmosphere of Saturn, the atmosphere of Titan, the surfaces of the satellites, and also their orbits, determining their orbits.
I just want to emphasize, because your detector was slightly better than our eyes in the spectral range, but was basically seeing what we would see if we were strapped to the spacecraft.
Yes, exactly. That's what I meant. They're like an extension of our eyesight put
Excellent.
there, our eyeballs put
Excellent.
there. I want to say though that where our eyes are much better photometrically than our cameras were, but that's another story too. So anyway, our science objectives were very broad, and our priorities in science anyway were to pick up where Voyager left off. And so we wanted to make sure that we could see down at the surface of Titan, because Voyager never saw the surface of Titan. We wanted to look for
Titan, one of Saturn's moons.
One of Saturn's moons, its largest moons, with a very thick, hefty atmosphere. And we wanted to check out whether Enceladus had plumes coming off its surface, because that was one of the ideas that was on our brains when we put Cassini together. What was the E-ring of Saturn created by a plume coming off Enceladus? And then we
But there's
wanted
an E-ring
to,
in the Pentagon, last I checked. So now we have an E-ring around Saturn.
Oh, yeah, the way the Pentagon is just as designed, there's 5 rings, aren't there? So anyway, we wanted to do a lot of scientific things, and so it was very big job. And we did all that. We saw down to the surface of Titan. We were the ones who first saw the lakes and the largest sea on Titan. We found the plume and the geysers coming off Enceladus. We found new moons, new rings, new phenomena. We saw mind-blowing details and just incredible things things we did not expect to see in the rings of Saturn. So it was just an amazingly productive mission scientifically.
So
Can I just say my other priority was to make sure that we presented our results in the most inspirational and clear manner possible, and I really wanted very much to make the rest of the world feel like they were riding along with us by just making our images gorgeous. So that was another very high priority.
Okay, so but this didn't come from nowhere, because reading your resume, you had some significant overlap with the Voyager, the very Voyager mission that you're saying this is the next best set of images that we would get of Saturn. Voyager launched in the 1970s. How old could you have been back then?
Well, how old were you? So I think what you're getting at is, you want me to say that I was part of the Voyager mission. I
think I got that on your resume. Is that right?
Yeah, yes. And believe me, that was like the best thing that ever happened to me. I feel like I've said this 1,000 times, I've led a charmed existence, and being part of the imaging team on Voyager was just colossally good. But I did my thesis on Voyager data of Saturn's rings, and then by the time I graduated graduate school, I was added to the imaging team and helped plan the Uranus flyby and the Neptune flyby. So that's why I thought, I don't know why actually, but I thought, I'll lead the next team going to Saturn, and that's how that happened.
Well, if you have the pedigree coming in, then you become the obvious choice.
I guess so.
But let me add to that. In Voyager, of course, Carl Sagan was very active with Voyager. So, and I remember how much care he invested in communicating the results of Voyager to everybody. And not only with his sort of fireside manner, but he was on Johnny Carson, The Tonight Show, doing so. And scientists never were on The Tonight Show. So did any of that kind of legacy spill over into you, for you to say, standing there flat-footed, that when you're taking these images of Saturn with Cassini, you want to make sure they come across to the public in the most inspirational way? Where did that come from?
Well, okay, so I cannot deny that Carl was a big influence, and everybody in our generation loved him. I cannot say the same for his colleagues, who quite resented and somewhat looked down on him for what they called grandstanding.
Just to be clear, our generation is slightly, about a half generation younger than Carl Sagan. So we were not sort of competing faculty with him. We were students on the rise.
We were students on the rise. We were actually one generation. He's 20 years older than me.
Oh, that's okay.
Anyway,
That's enough of a generation.
So anyway, he was just very inspirational to me. But, my desire to do the images in present them in a beautiful way actually goes back to the fact that I don't know if we have time to talk about this, but if I'll just riff and you pull out of this anything you want, it goes back to the fact that on Voyager, the images were processed in, red, green, blue color and all that, only for the press conferences. I mean, that had never been done before, that people actually put images together just to get the public excited. The public didn't matter to all the mission people that came before Voyager and came before Carl. So I saw that they did this just for the press releases, and they weren't the best. They weren't what they really could have been. And in fact, there was a member of the press corps. He was an amateur astronomer. His name was Andrew Young. And he criticized the Voyager imaging team for not doing a better job at making the images more presentable.
Well,
So I'm a
calling
young
you out. Wow.
scientist. Yeah, at really standing up at press conferences saying, you guys really, you're falling down on the job here. And I made a big mental note of that. And when I became the team leader, I thought, check, I'm going to do that. I'm going to make sure they really look good. So that was also a motive for me to do it. And because you do this too, Neil, you just, you want to share. It's just the joy of sharing knowledge. And how much better to convey the knowledge that we're finding than to have an image. If people really connect with images, it's that link between our visual field and our cortex, and the images like get right in there as a hook.
So I mean, it's amazing to hear you say this now. I shouldn't say amazing. It's very cool to hear you say this now, because in '97, when you guys are launching, we were not living in the age of the image, which is where we are now.
Yes.
So, here we have Facebook and Instagram and, the internet, and we live in an image-driven culture right now. And so you are literally, I would say, 17 or 18 years literally ahead of your time. That's got to feel good.
Well, it does. It feels very good, but understand what made the era of the image happen is the internet. In Voyager days, when we were sharing images, we weren't sharing images over the internet because there was none. People were mailing hard copy images to each other. Images to each other.
But wait, are the three of us on rocking chairs on a porch right now?
I don't know, Neil. I have to say, sometimes I feel that way.
Carolyn,
really
how's your rheumatism? Yeah, is it acting up?
I'm not going to tell you, but I'm still walking.
I think my knee tells me it's going to rain tomorrow afternoon.
Exactly.
So Carolyn, I think one of the more memorable images, memorable for its not so much for how spectacular it looked, but for what it contained, was the pale blue dot. And could you just give us a moment about what you remember about the pale blue dot back under Voyager, and what was your attempt to reprise that with Cassini?
Okay, so I think, as you said, and it's clear that the image itself wasn't the most spectacular, and it was, but it was a fabulous idea. And I often say this. I know maybe it sounds, I don't know what it sounds like, but I'm proud of the fact that I came up with the idea independently of Carl. Mm-hmm. We were both trying to work it through the JPL Voyager project. He was 3 years, I think, before I was. But
Jet Propulsion Labs in Pasadena, California.
Yes,
that was base camp for Voyager. Is that correct?
That was the days when the conduct of a mission was entirely centralized at the NASA center. In this case, it was JPL. Mm-hmm. That didn't happen on Cassini, but on JPL, everything happened on Voyager. Everything happened at JPL.
And just to catch people up, the pale blue dot is an image of Earth taken by Voyager after Voyager passed Neptune, looking back towards the inner solar system, and then you see this small dot barely filling a few pixels.
Not just a pixel.
Oh,
I think it was
not even a
just
pixel. Okay.
I think it was just a pixel, but it was a small little dot. Okay. And so I'll tell you, since we were talking about well, anyway, so Carl had this group of people helping him at JPL. I didn't know about it. I was also trying to get it done. Then in 1988, this is 7 years after Carl, or 6 or 7 years after Carl had started to try to get the picture taken. But the project didn't want to do it because they didn't want to spend resources. And I, too, in my attempts, kept hearing the refrain, why do you want to go through all that trouble just to take a picture of something that's going to be a pixel? No one copped on to it. No one got it. Carl kept pushing it with his small group of advocates. And then in 88, I found out that he was doing that. And I said, hey, I've been trying to do it too. And we joined forces. And I ended up being the person who computed the exposure times. Okay, so I did have, in the end, had something to do with his version of the project.
So,
but I'll tell you, let me just say this, because this is germane to what we were saying before. When the picture got finally taken, and Brad Smith, leader of the Voyager Imaging Team, his office is at University of Arizona, is like 3 doors down from mine. He calls me into his office, he says, come in, I got to show you something. And he hands me the picture. And it's black and a few streaks of light on it. And my first impulse is to take my hand and wipe the dust off it. And one of the pieces of dust I wanted to wipe away was the earth.
Wow.
And Brad says, exactly. Meaning, yes, it's only the size of a piece of dust. So the picture itself, I don't know if the picture would have had as profound an effect as it has had over time if it weren't for Carl, who layered meaning on it and made it clear what it signified. And it ended up signifying a call to all of us to regard ourselves as one tribe and to put the safeguarding of the health of our biosphere and our environment, to make them of paramount importance in decisions that we make in managing our existence on the planet. And that's why over all these years, it's become a powerful meme, has it not? Pale blue dot. You say pale blue dot, it immediately signifies, the smallness of Earth. We're all in this together, and this is all we got, and we better protect it. And it's all down to Carl. He's the one who made that happen.
Now, you reprised this at Saturn, right? There's a
I
picture
did.
I must have shown to the public 1,000 times.
And thank you, because I love that picture, and I'm glad you're letting other people enjoy it.
This is Saturn in the foreground, beautifully illuminated, and there's this dot in the background. And you zoom in, I say, whoa, that's Earth. So it's kind of like a pale blue dot for our next generation.
Yes, and it had a twist. So here's the thing, once you do something like you show people a new perspective, you open the door to people and they see something they've never seen before. They see themselves as they've never seen themselves before. It kind of gives them a new self-image. It redefines themselves. And once you do that, you can't really have that same impact again. It's why lots of missions have taken pale blue dots from the surface of Mars, from on the way to Jupiter. I mean, lots of spacecraft have done this. They don't have the same effect.
Right. So then, correct me if I'm wrong. Was that the image you took when you had everyone look up at Saturn and smile?
Yes, that's what I was getting at.
Oh,
that's what I was getting at. That I added this twist where I thought it would be great. Well, this occurred to me while I was planning it. It would be great to just invite people of the world ahead of time, let them know ahead of time that your picture is going to be taken from 1 billion miles away. Go out, look up, think about your existence, think about where you are, think about the uniqueness of our planet, and just smile at the sheer joy of being alive on a pale blue dot. And people all over the world did that. It was so, it was great. It was great.
So they looked up at Saturn from Earth while you were exposing the image.
Yes, that was the directive at this time. This is when the picture taking window opens. Go out.
Wow.
And of course, I didn't want to leave out half the planet because only half the planet could
Can be
see
seen.
Saturn.
Yeah.
So it was, for me, it was just, use the moment to appreciate the magnificence of what's happening and smile. Just smile at the universe, smile at being a part of it all.
It's a beautiful connecting moment, though. It's really cool.
You would have thought that I was the person who started it. Had been thinking about it for 3 years by the time it happened. When I was there at that moment, I was being interviewed by the BBC. I got as into it as I was hoping everybody else would. It was such a rush. It really was a rush. It made the solar system feel like a very much smaller place. It was great.
So let's get on to the Sacrifice of Cassini.
Yes.
As we all know, if you've seen the episode, there came a time when Cassini's mission was over, and we didn't want it to accidentally slam into a moon that we might want to investigate in the future for the possibility of life, because there could be microbes, stowaway microbes on Cassini. So we plunked it down into Saturn. So let me ask you, suppose someone handed you some extension money for Cassini, said, okay, you have another 5 years. What would you do with Cassini if you had another 5-year stay of execution? The governor says, no excuse.
Exactly.
You will be surprised, but I personally would do nothing, because we had that whole thing planned so well that by the time we sent it on its way, the fuel was being exhausted. A lot of the instruments were starting to degrade. We had squeezed every delicious bit we could out of that mission. And I would have said at that time, if someone said 5 more years, I would have said we should take the resources that would be spent here and put them to the next mission, which could be better equipped to follow on from Cassini, like we followed on from Voyager, and now ask the questions that Cassini has left behind. And you couldn't do that with the Cassini instruments.
So then that begs the question, what is the next mission?
Well, that's being debated. These things are always very hotly contested. There are people who want to go to Europa.
Well, I just want to interject here that it was highly enlightened of you to say to yourself and to others, Cassini's useful time is done. We could hang on to it, but there are other missions, and this money would be kept here instead of going to other missions that can extend this
streak
quest
of discovery. Yes.
Exactly. So I just want to congratulate you for that level of insight and foresight for how science works. So.
Okay, thank you. But no one ever asked me that, Neil, except you.
Okay.
So next mission. So what would we do? To me, you might get different answers from different scientists, but for me, the most thrilling question that we have in planetary exploration before us is whether or not there are organisms on other planets. The real holy grail would be if we could find that life had originated independently of Earth. I don't know that we'd be able to prove that 100% because there's material that exchanges back and forth. But when you get to the outer solar system like Saturn,
but just to be clear, so people know what you mean, in the solar system, you can have sort of asteroid impacts on one planet that can cast rocks into space that then land on other planets. So there's an exchange of material that's been going on for billions of years.
And it's happened a lot between Earth and Mars, right? We have Martian meteorites here that were delivered that way. And so people have done calculations. What are the chances that something from Earth or Mars could have gotten out to Saturn and landed on Enceladus or landed on Europa, on Jupiter, and so on. So, but anyway,
so when you say microbes on other planets, I presume you mean on the moons of other planets.
I'm sorry, I mean on the moons of other planets.
Right,
yes,
right.
Yes.
And Enceladus is one of your babies, right? Wasn't Enceladus one of your research interests?
Well, I started out as a ring scientist and doing work in planetary rings. But when we found what we found at Enceladus, I was so blown away. I thought, this is a place, because we figured out right away that it implied liquid water and the presence of liquid water. We have since learned that those geysers that you see and those beautiful, spectacular images, that liquid water could possibly be reaching all the way to the surface. I mean, all the way to the surface. So it doesn't really, this is often said, it's like a cliche, but it doesn't get better than that when you're thinking about a habitable zone. You want to, that could have life, that's what a habitable zone is, and a way to sample it. Because with Enceladus, the ocean underneath its ice shell, its habitable zone is expressing itself into space.
So what you're saying is, I think what you're saying is, you could go to Enceladus, and rather than have to dig through this multi-kilometer thick sheet of ice, if there are geysers carrying water from below to the surface, then any fishes or microbes get carried with it, and then they land on the surface. And so you can go there and find freeze-dried fish, possibly.
I don't think, well, I think if there was a lot of freeze-dried fish, we might have seen a spectral signature of them. But to be honest, I've never taken a spectrum of a fish. So I don't really know.
Yeah, you only know what you're looking at if you have a lab sample from back here on Earth.
Okay, so somebody watching should go and take a spectrum of a fish. We'll test Neil's hypothesis, but I don't think we have fish on the surface. You know, we're scientists. You know, we're rather conservative and boring. We'd be happy with microbes. It's not out of the question that there could be microbes there on Enceladus. And so
what is the process? Do you fly by and through a plume, collect and return, or do you land? I mean, how do you envision a mission like that taking place?
Well, funny you should say that, because there's a big activity right now going on in the planetary science community where people are discussing that very thing. What can you do with one type of mission, like maybe just a repeat of Cassini? You orbit Saturn and you just repeatedly go through the plume of Enceladus once every orbit around Saturn. Of course, you'd be outfitted on your spacecraft with a completely different set of instruments. So it'd be much more, you could do much more than Cassini could do, but that's a limited mission. There's also the possibility you could get into orbit around Enceladus, and then you're flying through the plume every Enceladus orbit, which is like an hour and a half, and picking up a lot of material. My favorite, of course, is landing on the surface, because then all you got to do, since the material, the icy portion of it anyway, the tiny frost particles, go up and 96% of them come down to the surface. All you got to do is go down, open up your collector plates and let the stuff snow on you, and then ship that stuff off into your various instruments. And there's a lot you can do there because you're collecting material all the time. And
so that's almost as good as a sample return, because you already have the sample and you just put the right instruments there with your space probe, and you don't need to bring this stuff back if you can analyze it on the spot, right?
Well, that's true, but Baron, I mean, I'm not a big fan of sample return because it's very risky. It's very expensive for what you get. You just get like micrograms worth of stuff when you could have lots more material by just going there.
So plus, if it's your mission and it comes back to Earth, you don't want it to be responsible for the Porco virus. That you don't want that.
That's right. Yeah, there's always that. There's planetary protection. That's a big issue. But we have to worry about forward protection if we land on the surface. So that's a big thing you have to think about. But
so we got to bring this to a close. Just a quick forward protection. Why can't we just sterilize our spacecraft?
The problem is that sterilizing your spacecraft, when some of the instruments that you want to carry actually involve bringing organic material with you.
Oh.
Okay. I mean, there's, I think they're called assays, where they bring material along, and if you take a bit of the stuff, you capture it and you stick it in that little pot, or stick it in that little pot, you examine what happens, and that's your measurement.
In an organic soup of some kind.
Yeah, so it's the techniques you would have to use to sterilize your spacecraft could ruin your experiment. So it's going to be a sensitive balance. I don't know what's being actually what they're thinking about these days for planetary protection.
All right, Carolyn, it's really, as always, great talking with you, hearing you reflect on your life and the life of our field. And thanks for joining us for this sort of recap of Cosmos Possible Worlds, Episode 8.
Well, thank you very much for having me, as always. It's great to see you guys again. Glad you're still kicking.
We are still kicking.
Absolutely, yeah.
Chuck,
Yeah.
always good to have you there. And you've been watching,
Always.
possibly listening to StarTalk Chat Room, a deep dive into the cosmos. I've been your host, Neil deGrasse Tyson. Until next week, where we'll cover episodes, I think, 9 and 10 of Cosmos Possible Worlds. Keep looking out.